Now we're going to look at geometric probabilities, arcs, and sector areas. Arcs and sector areas come into play a lot in probability. So first of all, you've been dealing with probability since really 5th, 4th grade, definitely 6th grade, and middle school. And you learn that probability is a number between 0 and 1, or 0% and 100%, that tells you how likely something is to happen. To calculate the probability, it's still the same. You find the ratio of favorable outcomes to total outcomes. So you can see here on the top I have the favorable, and on the bottom there's total. Well, for geometric probability, it's pretty much the same idea. You're just going to be dealing with probability based on the ratio of areas or lengths. The denominator will be the total length or area. So in this example, if you randomly choose a point in the circle with a radius of 7 centimeters, you can see there's the center, there's a 7, and here's a 7 and 7. What is the probability that it will be in the triangle? Well, first of all, I'm going to go ahead and find the favorable area, which is going to be this area in here. What is the likelihood it'll be in here if it has to be in the circle? Well, I'm going to find the area using our formula chart, 1/2 base times height. The base, since it's 2 radii, will be 14. The height is 7, so I substitute in 1/2 14 times 7, and I will get 49 centimeters squared. I also need to find the total area of the circle. So I use pi r squared, and the radius is 7, so it's 49 pi. To do the probability, I'm going to take this favorable, the 49, and put it over the total area. So it's 49 over 49 pi. You can see that the 49 simplify, and I get 1 over pi. So you could actually leave that as your answer. For probabilities, it's great to leave your answers in fractional form. We also accept decimal form. Should always be a number less than 1. For percentage form, it has to be 100% or smaller. Now the complement, what is that? The complement makes up the rest. It comes from the word complete. And oftentimes when we're talking about the complement, we will use the word not. So like not in the triangle. The probability of an event plus the probability of its complement always have to add up to 1 or 100%. So the probability that it's going to rain today plus the probability it won't rain today must add up to 100%. If it's a 20% probability of rain, the probability of no rain would be 80%. Or if it's a 0.2 probability that you'll have a quiz tomorrow, and it's a 0.8 probability that you won't have a quiz. They must add up to 1 or 100%. So in the previous example, what is the probability that the point won't be in the triangle? Well, I can just take my answer and subtract it from 1. 1 minus 1 over pi. And honestly, that answer is just fine. For my pre-AP kids, I'm going to go ahead and get a common denominator so I can write it all as one fraction. Pi is irrational, so it's kind of weird to use that word with pi. So both of these answers are perfectly acceptable. Now, some questions on this first page of notes. At what probability is something certain to happen? It must happen at what probability? At what probability is something impossible? Will it not happen? What goes in the denominator for geometric probability? And how is the probability of an event related to its complement?